All right, Chem 30s. Welcome to your first online class, I guess we're gonna call it. So we're gonna start with organic. We figured this would be as soft an introduction to this whole online learning thing that we're doing. So I know I gave you guys the notes and the question package before the break. So what I'm basically gonna do is first part of organic is all the different functional groups. So we're just going to kind of do little short mini lessons on each one of those. And then the second part will be on the different types of reactions, and same deal. I'll kind of break it up, try to make them short, manageable sections so that you're not stuck at your computer for hours on end. Okay, so first thing to do is basically to define what is an organic compound. When we talk in chemistry, we often talk about organic versus inorganic compounds. So organic compounds is anything that has hydrogen and carbon. For the most part, those are the most important things. We're going to have carbons along the main chain and hydrogens all kind of sticking out of them. Sometimes they can have oxygen, nitrogen, sulfur, phosphorus. You're going to find in Chem 30, we don't deal with the nitrogen, sulfur, or phosphorus. It's only going to be the nitrogen, or sorry, not the nitrogen. Why am I saying nitrogen? It's only going to be the oxygen that we're also going to deal with, okay? So anything that doesn't have carbon and hydrogen is classified as inorganic. So if you think back to bonding, I know it's been a while since we've done bonding, we have to remember that carbon has 4 bonding electrons, right? Remember when we drew out our lovely little dot diagrams last year, we always had our symbol. So we had carbon, it has 4 valence, so we kind of had this general setup here, okay? So what that means is carbon always wants to make 4 bonds. So whether it's because there's going to be 4 single bonds, 2 double bonds, a double bond, and 3 singles, it doesn't really matter, but ultimately it has to be attached to 4 things or have a total of 4 bonds, okay? So shape-wise, we're going to start with things in chains, and then we're going to move to other different types of shapes as we work through them, okay? So biggest thing when it comes to recognizing what is going to be organic or not, there are definitely some common ones. I don't want to say that they try to trick you with, but there are definitely some common ones that they give you that are not going to be organic, okay? So just to give you an idea of what some of those are, and I know this is totally not the right spot to write this, but carbon dioxide would be one of those, right? And we often fall for carbon dioxide because we're like, oh, it has carbon. But the problem with carbon dioxide is there's no hydrogen. So that is not organic. Same deal with carbon monoxide, right? Again, it's just CO. Okay, there are a couple of molecules though that have C and H that we think are organic but are not, okay? And the 2 most common ones for that are carbonic acid, right? It's H2CO3. Sometimes we look at that and we're like, oh, but it's got H, it's got C, it's got O, we're in business. But nope, not organic, okay? And then the last one that they often get you with is the HCN. Okay, so these 4, you should be aware, are not organic molecules, okay? Other ones that they sometimes throw in the mix, because usually this shows up as a numeric response, is things that have metals in them, okay? If you have a metal, you're automatically not going to be organic. You're going to find as we go through the different types of groups, we're going to talk about different properties. So that's where we'll talk about whether they're soluble in water or some other different solvents that we have. Okay, so my screen is not liking that, but you have the slide, so you know that it says different formulas for organic compounds, okay? So when we look at formulas, there's different ways that we can be given formulas, okay? One of them is what we call an empirical molecular formula. So an empirical molecular formula just shows you how many C's and H's there are. So an example of that would be if we had C5H12, right? That tells me I have 5 carbons, and it tells me that I have 12 hydrogens. but beyond that, it doesn't really tell me too much. Okay, so then we move to an expanded molecular formula. So if I gave you that exact same formula, okay, that didn't do what I wanted it to do. If I gave you that exact same formula, I could write it differently, and I could write it as CH3 and then CH2, then CH, and then in brackets, a CH3, and then another CH3. Okay, this looks different than the C5H12, but if you count it up, assuming I've done the math right, it should still have 5 carbons and 12 hydrogens. So this one starts to give me a little bit more information. Okay, again, you kind of have to think back to bonding, where it went central atom, what's on it, the next central atom, what's on that. Okay, so the brackets around that second last CH3, those are telling me that something is branched. Okay, that means it's coming off of that main formula. Okay, so it starts to give me a little bit more information, but I'm not quite up to a diagram yet. So when we move to structural formulas, this is where we start to get things more as a diagram. I'm going to do my best to draw this, but as you know from me doing this a few times in class, it's really hard to use a trackpad to do this. So same molecule, we're going to have our C. Okay, it had 3 H's. So remember last year we put one on top, one on the side, one on the bottom. Okay, so there's my first CH3. So that's taking care of this part. Now I move to the next part. So now I have a C, okay, and all the C's kind of always go in the middle for the most part. That's why we call them our main chain. It has 2 H's, so one goes up, the other one goes down. Okay, then we have our next one. So our next one just says CH. So I go to my C, and I have my H up here. Okay, then we said those brackets meant something was a side chain. So that means this CH3 here isn't going to keep going across that straight line. I'm either going to put it above, but I already have something above, so I can't put it there. I'm going to put it below. So in this case, I'm going to put that C with its 3 H's down here. Okay, that was the only thing in the brackets, so that's the only thing that goes here. Okay, then we go back to the main chain. Sorry, try not to cough. And then we have that last CH3. So we put in a C with its 3 H's. So structural formulas are great. They show you where absolutely everything is. But as you can see from my painful demonstration, it takes a really long time to draw, especially the way I have to draw right now. So I don't want to say we don't use them. We definitely do use them, but we don't use them as often just because they're so big. And when we get into bigger molecules, which we do, they take up so much space. So that takes us to a condensed structural formula. Okay, so the difference in the condensed structural formula is just that we're not going to show all the H's sticking off like we just did. Okay, instead, they're going to just be written next to it. So how this is going to look is I'm going to have my CH3. Okay, so instead of drawing those H's separate, we just draw them all together. Okay, we're still going to show our bond, right? So there's our bond. Then we had our CH2. There's our next bond. Then we had a CH. Okay, and then in that main chain, we had one more CH3. Oh, I didn't hit the right button. Hold on. Okay, then we had that last little side chain, right? So, sorry, I'm going to switch between two things because I don't know how to do that with just a computer. And so coming down off of this one will be that last CH3. Okay, so condensed structural formula still shows you where things are. They just kind of bring the H's in, okay? That's probably, I would say, the more common formula that we tend to use just because it still shows us where things are, but it doesn't take up so much space. All right, last type of diagram is a line diagram. This one at first looks really wonky, but we'll kind of ease into it. We'll start all the alkanes, enes, and ines for the most part, just doing condensed structural, and we'll hold off on the line diagrams, and you'll see when we get to it, it shouldn't be too bad. So the way a line diagram works is completely different. It's literally just lines. We don't show hydrogens. We don't even really show carbons. The way we show carbons is a start or an end of a line. So if you look at that condensed structure we just did, it had 1, 2, 3, 4 carbons in the main chain. So how this is going to look, I'm going to start my line. I'm going to go up. So this is showing me that there's 1 carbon here and there's a 2nd carbon here, but we said there was 4. So we're going to bend it down to the 3rd. So now there's 1, 2, and then 3, and then bend back up for 4. Okay, so there's 1 here, 2nd here, a 3rd here, and a 4th over here. Then we had this little side chain coming off. And so it was on the 3rd carbon. There's only 1 carbon in it. So we're going to bend down for that one. Okay, so those are your kind of, I guess I would say, 3 main types of diagrams. Okay, you're mainly going to find that we're going to use line diagrams a little bit later on. For now, probably more of the condensed structural and the structural. Okay, so that's kind of your intro to organic molecules, what an organic molecule looks like, what some of the different ways of drawing them are. Okay, next video is going to show you our first different type of organic molecule.